Hello, in this video I will be talking about direct variation. The definition of direct variation is a relationship that can be represented by a function in the form y equals kx. What that means in English is a relationship that means anytime two unknowns or two variables can be represented in an equation. So for instance, in the marching band example from yesterday, we have time as one of the variables and distance, and they are related. The more time that has passed, the more distance that the band marches. And so direct variation means the relationship that can be represented by an equation, but with direct variation, specifically the equation has to be in this form. And so we'll talk about what that means. The y and the x are familiar with you guys. In the case of the marching band, I believe x is minutes and y is feet marched. But the k is new, kind of. The constant of variation is what the k is called. It's the coefficient of x, meaning it's a number that will be in front of x. We know it from the last chapter as the common difference. Okay, so for instance, in the marching band example, the k, the common difference, is 260, right? With each minute, we have 260 more feet. 260, 260. Okay, so now we're going to call that common difference the constant of variation. So the first thing we're going to do with that is we're going to determine if an equation represents a direct variation. So for instance, in example 1 here, we have 6y equals 5x, and we're going to figure out if it is in fact a direct variation or if it's not. Well, direct variation has to be in this form, y equals kx. So the first thing we're going to do is solve for y. To do that, we're going to divide both sides by 6 because we're just going to isolate y. That's the goal. So now we have y equals 5 over 6 times x, also known as 5x over 6, either way. So this is y equals kx, right? We have y equals some number, it's a fraction, kx. So in this case, k is 5/6, and it is a direct variation because I am able to put it in that form. Okay, let's take a look at one that is not. So in this example, we're going to solve for y again, just like we did in example 1. And I'm going to make this negative 3x plus 7. I could also write that as 7 minus 3x, but I'm doing that for a reason I'll show you in a moment. So I'm going to solve for y. We have to divide both sides by 4. And what that means is I can either write negative 3x plus 7 over 4, but I could also write it like this, negative 3/4 x plus 7 over 4. What's important to see here is that in the direct variation equation, there's nothing added or subtracted from that x term. Okay, I do have a k in this case, which would be negative 3/4. But there's also this fraction being added. That is not acceptable for a direct variation, so this is not a direct variation. Okay. What that means in actual terms of data, if we were to look at this marching band example again, a direct variation always has to have a 0, 0. So for instance, if the marching band goes for 0 minutes, the distance would be 0. Okay, and that won't happen in this case. So how to write a direct variation equation? So let's suppose that y varies directly as x, which means direct variation, and y equals 45 when x equals 9. What direct variation equation relates x and y? Let's start there, and then we'll get to the second question in a moment. So we know that the direct variation equation is y equals kx. So if we plug in the value of y that we're given in this problem and the value of x that we're given, we'll get 45 equals some value k, which we're going to figure out, times 9. Okay, so we know that 45 equals 9 times k because we know that y equals 45 when x is 9. So we just plug those values in. So I'm going to solve for k, divide both sides by 9. and I'm going to get k is going to be equal to 5. So I'm almost done. I just was figuring out what k is. The actual equation is this. We write y equals, and then we substitute the value in for k, and then so y equals 5x is the direct variation equation. And you can tell that it works because if we plug in x here, 9 times 5 is 45. So now we're going on to the second question. So here's the answer to the first question. The second question is, what is the value of y when x equals 6? So we're going to use this. So what is the value of y when x equals 6? We're just going to plug in 6, figure out what y is. Pretty simple. Y equals 30. So that's the answer to the second question. So here's this in an example. We're going to figure out how to graph a direct variation, which is basically the same as graphing any equation. So let's say the weight of Mars, or it actually is, the weight on Mars, y, varies directly with weight on Earth, which we'll call x. The weight of the science instruments on board the Phoenix Mars lander on Earth are 130 pounds. On Mars, the instruments weigh 50 pounds. What is an equation that relates weight in pounds on Earth and weight on Mars? So we're going to use the equation y equals kx for direct variation. And we know that y is going to represent the weight on Mars. I'll call that m right now for Mars. And we're going to figure out k. And x is going to equal the weight of Earth. I'll write e. The weight on Earth, not the weight of Earth, sorry. And the weight of the instruments on Mars is 50 pounds. K we're going to figure out, and the weight of the instruments on Earth is 130 pounds. So by solving for K, we figure out that K is equal to 50 over 130, which reduces to 5 over 13, which is approximately equal to 0.38. We just need an approximation because when we're graphing, we're not going to use a small enough scale so that any thousandths of a decimal place are going to matter. So in this case, 0.38 will work just fine. So now we just need to make a table of values. So we know x and y. And I'm going to pick x values that are simple because we're dealing with 0.38. I don't want to do a lot of math when I don't have to. So if I choose an x value of like 100, for instance, when we multiply 100 times 0.38, we're going to get 38. If I multiply 200 times 0.38, it's just double that, so 76. And multiply by 300 times 0.38, we're going to get, what is that? 114, it looks like. So now we're going to graph that. Made a graph over here. So I have the x values here on the bottom, the y values on the vertical axis. So we could just make some points here. So at an x value of 100, y is going to equal 38, which is about right up here. And with an x value of 200, y is 76. So that's going to be about right here. And with an x value of 300, we get a y value of 114, which is up about, there's 110, so 114, about right there. And so you can see this direct variation went through the origin at 0, 0, and it basically goes through like so. So that is how to graph a direct variation equation. Let's go on to the next example. So if we need to write a direct variation from a table of values without seeing an equation or reading a word problem, all we need to do is remember that the equation for direct variation is y equals kx. Then we need to plug in values. So when y was 7, when x was 3, and then we can figure out here that k equals 7 over 3. We also know that y was 14 when x was 6. And so from that second one, we can see that k equals 14 over 6, which reduces to 7/3. So far we've checked 2 of these, and they have the same constant of variation, which will be necessary. Let's try one more. So y was 21 when x was 9, so that's a k value of 21 over 9, which does reduce to 7/3. So knowing that these all have the same constant of variation, the formula is going to be y equals 7/3 x. Because remember that k, that constant of variation, is what we found out for each one of these. So let's look at example 2. Not every table of values is going to have a direct variation. So in this case we have y equals kx again. So we have 8 equals k times 4, which leaves us with a constant of variation of 2, 8 divided by 4. Then we have 16 equals k times 8, which again will leave us with a constant variation of 2. Then we have 20 equals k times 12, which is not a constant of variation of 2. It's actually 10/6 or 5/3. So rather than writing an equation for direct variation here, we know that this actually is not a direct variation. And that is going to do it for this video. Thanks for watching.